Hello guys, good afternoon. Belinda here to present your session today. Hope you are well and staying safe. Okay, so I'm just going to allow a couple of minutes for you guys to turn your audio on if you're struggling to hear me. Okay. Turn your audio on and make sure your speaker volume is turned up. Please also note that you are automatically muted when joining the session. So if you've got questions, please type them in the question box. Also, please take note that you will not be seeing me today. We are doing so that we can, so you can hear me properly to avoid any connectivity issues. My camera has been turned off. Okay, so please take note of that. Should you have any questions, please use the question box. And then again, download the presentation on the handout section. Okay, this video will be available on YouTube. If you've got any questions that you couldn't post during the session, please send them to academics@impact.co.za and you will receive feedback. Okay, just going to allow a couple of minutes for everyone to settle. Okay. While I wait, who has received this term's practical investigation? Can you please raise your hand if you have received this term's practical investigation? Okay. Do you have it with you? Do you have it with you? Raise your hands if you've got it with you. I'm going to unmute you and I want you to tell me what the investigation is about. If you've got it with you, please kindly raise your hand. I'm going to unmute you so you can tell me what it's on. What is the investigation about? We'll be doing scientific reports today, so if I have an idea of what they have asked you, then we can tackle some of those questions as we go. Who has it with them? Please raise your hands if you've got the practical investigation with you now. Somebody typed in the question box. Yes, the investigation regarding genetics. What is it about? What are you required to investigate? Let me see who's got their hand up. Okay, nobody has their hand. Oh, there we go. Hi. Hello. I cannot pronounce your name, but I think you are Suma. I've unmuted you. Could you kindly tell me what the investigation is about? Okay, if you're not comfortable, please can you just write it in the question box. What is the investigative question? Can you write it in the question box for me, please? It's task 4, I think, yes. What are you required to investigate? All right, in any case, we're gonna start now. Okay, so in today's session, we're gonna be looking at a scientific report, okay, that needs to be written when conducting a scientific experiment or a practical, okay? So by now in grade 12, you must have conducted a couple of experiments from grade 10, grade 11, and grade 12. So by now you must be a bit clued up on what a scientific report is and how you conduct a scientific or a practical experiment. So, and you know that this can be a task on its own. So you can be required to conduct a practical experiment that counts towards your SBA task, usually 40 marks, and it counts as a percentage towards your final mark. Okay, so this can be a practical task on its own, or it can be a question that is examined in your examination. So they normally sometimes give you a practical investigation. So not an investigation that you need to conduct per se during the examination, but it's something that you have knowledge on, that you have prior knowledge on. Okay, so they can ask you a question in an exam on that. They can ask you to write the scientific report on that particular investigation. Okay, so it's very important that you know and understand how to write a scientific report, right? Like I say, it can be asked in your exam for you to write your scientific report. Okay, so today we're going to be looking at how that is done. Okay, and hopefully this lesson will enable you to better answer your task, your practical task that was given to you. Okay, so a scientific investigation is a way of learning science through practical work. Okay, so scientists try to figure out how the natural world works by conducting experiments. Okay, these experiments are used to observe something else to change. So they use experiments to observe or measure if changes to one thing cause something else to change. This is called the cause and effect method. Okay, we change something and we see what effect it's going to have on another thing. These two things that I'm talking about are known as variables, and we're going to be going into detail into the type of variables. Okay, so scientists conduct experiments using the cause and effect method. They change, see if it's going to cause something else or another variable to change. Okay, so after conducting their experiments, they will need to write a scientific report. So what do you do? So when conducting a practice, to do is want to know how you can get a lot of followers on TikTok or YouTube or Instagram or whatever social media that you're interested in. Okay, you want to know how you can get a lot of followers on TikTok. I know that's not a scientific investigation per se, but it can help you get an understanding, a better understanding of what I'm talking about today. So first thing that you need to ask yourself is, what do you know already about TikTok? You will know that there is quite a large population of people who are tuned in there, and they are more or less interested in this type of videos. So you'll try and see what you already know about TikTok. What do you want to know? I want to know how I can get people to follow me, how I can get a lot of followers on TikTok. Okay, that's your investigative question. Okay, next step that you need to do is hypothesize, or find or write down your hypothesis. Your hypothesis is an educated guess on what you think will happen. So you will have studied some of the trends that are going on there, and from there you can guess what you expect to happen from conducting your experiment. Okay, a hypothesis is, what do I think will happen? Okay, or what am I trying to prove? All right, you can say, I'm trying to prove that if I post lots of workout videos, people are gonna follow me. Or if I become a very funny person who doesn't make a lot of sense, people are going to follow me because people like funny people. Or if I post videos of myself with makeup on, looking good or whatever, people are going to follow me because people like seeing people looking pretty or handsome or whatever. So that's your hypothesis. You think people will follow you based on it's an assumption that you are making. What do you do next? You test. Okay, so you are going to try and create either workout videos or funny videos, or post yourself with beautiful clothes and see if your number of followers will increase. So you test, you run the actual experiment. After that, you observe. After changing some of these variables, after posting videos of myself being funny, has the number of followers increased? You observe, you see what's happening. Okay, from there you record your results. Okay, you record your results, you check how many followers you have, you record your results. After recording your results, you present them, okay, for better interpretation, so you can easily interpret them in future, or whoever has a look at your scientific report can easily interpret your findings. You present them with the use of a table or a diagram. Okay, from there you reflect. After finding after observing your findings and presenting them, you reflect on what you found. So you reflect, you use your hypothesis against your findings to see if your findings agree with your hypothesis. After posting more workout videos, did indeed my followers increase or not? Okay, so sometimes your hypothesis, your findings can prove your hypothesis. Sometimes they disprove your hypothesis, but disproving it does not necessarily mean you are wrong. Okay, disproving something is just as important as proving something. Okay. So before we conduct any lab work, we need to make sure that it is safe to do so. Before we conduct a practical investigation, we need to make sure that it is safe to do so. A hypothesis does not have to be accurate or correct. There is no wrong or right hypothesis. Okay, it's what you think. It's a guess that you're making, but it needs to come from prior knowledge. It needs to be backed up by something you know. You cannot just make a random guess. Okay, so a hypothesis, there is no wrong or right hypothesis. Okay, remember, it's what do you think is going to happen. So nobody can mark you wrong because you thought differently from them. Okay, back to safety. There's a couple of precautions that you need to take before you conduct any lab work. Okay, number one, long hair must be tied back. Okay, number two, avoid eating or drinking during a lab experiment. Number three, stand up during an experiment. Number four, secure loose clothing and wear lab coats. This is if you are wearing a tie or something that's loose, make sure it is secured. Tie must be tucked inside your shirt. Number five, use suitable eye protection such as safety goggles or face shield. Number six, always place hot objects on a heat-proof map. This is just some of the precautions. There's a lot more. Okay, this can be asked in your exam as well. What safety precautions can Claudia take before conducting or during the experiment? Do not heat flammable substances directly. Okay, rather use a hot plate. Substances usually come with precautions. They will put stickers on if it's flammable, or or what to do if it gets into your eyes or your mouth. So normally substances come with that. Okay, so have a look at that before you start your experiment. Okay. So first thing that you need to do is you need to plan. In your plan, you focus on what you are investigating and how you will achieve it. Okay, so a couple of questions that you need to ask yourself. What am I investigating? What am I expecting? That's your hypothesis. This is your aim. What will the variable of the experience be, or what will the variables of the experiment be? We'll look at the type of variables just now. What information should I collect? What apparatus will I use to conduct the experiment? Okay, if it's a TikTok video that you want to do and you want to post workout videos, you need skipping ropes, you need dumbbells, you need nice gym wear, you need a phone with a good quality camera, you need internet, and you're going to start posting videos and so forth. If it's a photosynthesis experiment that you're conducting, you're going to need a leaf, you're going to need sunlight, you're going to need iodine solution to test if there was starch that's produced. So different experiments need different equipment or apparatus and so forth. What method will I use? Okay, and then other questions that you need to ask yourself: how will I make the experiment fair? Okay, because if it's biased, you might not get accurate results. Or if you are manipulating it so that it suits your hypothesis, then it's not going to be a reliable experiment. Okay? How will I collect data accurately? How will I keep safe? Those are some of the questions that you need to be asking yourself when planning an investigation. Okay, when writing a scientific report, the first thing that we look at is the aim. Okay, an aim is a description of the purpose of the experiment. What do I want to learn from this experiment? Okay, examples of aims are: test whether starch is produced during photosynthesis. Okay, test whether light is necessary for photosynthesis. Okay, test whether temperature increases the rate of transpiration. Okay, test whether TikTok makes you cool. So some of these tests will help you, because if you know that temperature increases the rate at which a plant transpires, if you don't want the plant to lose water, then you know you must decrease the temperature, because we have seen that an increase in temperature increases the water loss of a plant. So this helps so that in future you can make informed decisions when you're dealing with plants or animals or whatever it is that you work with. Okay. All right. So if you've got questions, please type them in as we go. Please type them as we go. I will have a look now and then to see. Right. So first thing, scientific, the investigative question or the aim. Next thing that you need to do is, after you've discovered what you want to investigate, you need to formulate a hypothesis. Remember what we said a hypothesis is? It's an educated guess on what you think the results of the experiment will be. Okay, this is not a random guess. Although there is no wrong or right answer, you can't just make random guesses. You need to make a more informed guess since you have learned these things before. Okay, you've learned about photosynthesis and you know that light energy is needed for photosynthesis to take place. So although you guessing, it must be an educated guess. All right. Variables. So we said we need to know what variables are needed in the experiment. So we've got a couple of variables. We've got fixed variables, we've got independent variables, we've got dependent variables. Okay, let's start with fixed variables. In order for us to get accurate results, some of our variables need to be kept constant throughout the experiment. Those variables are known as fixed variables. Let's have a look at our TikTok followers experiment. I said a couple of things could help me get a lot of followers. I said if I post workout videos, I said if I post funny videos of myself, or fashionable makeup, looking nice, pretty, or whatever. I said if I change these things, if I put this into effect, I can get a lot of followers or an increase in followers. Followers, excuse my handwriting, that's followers. So this means I'm going to try and post workout videos and see if it increases my number of followers. I'm going to post funny videos and see if it increases my number of followers. I'm going to try and post fashionable and see if it increases my number of followers. But in order for me to know which of this variable is effective enough, I can't do it all at the same time because I won't be able to measure which one it was. Okay, so while I investigate one of them, and that's what I need to do, I must investigate one at a time. While I investigate one of them, the others must be kept constant so I can tell which one is the winning one. Okay, so when I post workout videos, I need to make sure this are kept constant. I'm not posting any of this. Okay, this will be called the controlled variables in this case. Okay, the ones that are kept the same throughout the experiment. This helps in making my experiment valid. Okay, for example, I want to measure what the rate or what the effect of light is on photosynthesis, on the rate of photosynthesis. But there's other things that could affect this, like carbon dioxide. This is just an example, like carbon dioxide. So maybe sometimes if I don't keep some of these things constant, then they will have a role in the rate of photosynthesis, and I won't really see if this light is affecting photosynthesis or not, because there's other things here at play. So please try and keep some of those variables controlled so you can have a better judgment of what is working and what is not. Okay, so those are fixed variables. The next variable that we need to learn is independent variables. Independent variables are the ones that you, the investigator, is changing. Okay, in this case, we are changing the way or whatever, the things we are posting. Okay, those are our independent variables. We are changing them to see if it will change our amount of followers. Okay, so the dependent variable is the factor that you measure in the experiment after changing that variable over there. Okay, so independent variable, you change, or in math we know this as the input or the x values, the input values in math. And if you were to draw them in the graph, the input values are on the x-axis. So normally you give yourself x values, okay, and then you use those x values to find your y values. Okay, this is your input, this is your output. Okay, so these are your independent variables. You have control over them, you change them, you pick them. It's entirely up to you. These ones happen because of that. They are dependent on that. They cannot happen by themselves. Okay, so independent variables is what you change. The dependent variable is what you observe. Controlled variable is what you keep the same. Okay, if you've got questions, please send them through as we go. Okay, let's look at an example for determining the variables in an experiment. So we are given that experiment to conduct. How does the size of a cat affect how much it eats? This is what we are investigating. We want to investigate if the size of a cat or a dog, the size of a dog has an effect on how much it eats. Okay, so to conduct our experiments, we're going to start with a smaller cat and record how much food it eats. And then we're going to get a medium one, record how much food it eats. And then we're going to get a bigger one, record how much it eats. So we're going to see if there is a change in the amount of food these dogs are eating depending on their sizes. That's what we're trying to measure. Okay, we're going to try and see if changing the size of the dog affects the food that it eats. Okay, so let's look at the variables here. The independent variable is the size of the dog. That's what we change as the scientists, because we want to measure how much food the dog eats. So that's our dependent variable. Okay, we want to measure how much food the dog eats. The control, there's certain controls that we need to put in place in order for our investigation to be reliable. We need to make sure that we keep the hunger of the dogs constant. So this means maybe this one is going to eat a lot because it's hungry, and not necessarily because it's got a, I mean, not necessarily because it's small and small dogs have big appetites. Maybe it was more hungry than this one. So we have to make sure that it's constant. The level of hunger between all three dogs is constant, so that we know we are only measuring this, we are only looking at the size against the food, and no other variable will have an effect. So things like hunger needs to be controlled, and maybe the time at which the dogs eat need to be the same. Okay, you must decide we're gonna feed them in the morning. So today we're gonna feed the smaller one, measure how much food it eats. At exactly the same time tomorrow we're gonna do another dog, and so forth, and so on and so forth. Okay, so the next thing that I want you to do now is I want everyone to participate. Try and participate. Okay, we are going to look at a couple of experiments, and as we go, I want you to tell me what the independent and the dependent variable for each experiment is. Okay, I'm encouraging everyone to participate so you can have so I can have an understanding if you guys understand this, or if we need to look at it. But I'm encouraging everyone to participate. Okay, let's start with the first experiment. Light color causes changes in plant growth. Okay, this is an experiment. We want to see if changing the light color will cause a change in plant growth. Okay, so two variables here, light color, does it have an effect in plant growth? In the question box, can you tell me what the independent and dependent variables of this experiment is, guys? Okay, in the question box, please tell me which is the independent variable and which is the dependent variable between light color and plant growth. Okay, in the question box, I'm going to give you a couple of seconds or maybe a minute to answer that question. Will changing light color change plant growth? Which one is the independent variable and which one is the dependent variable? Does a change in light color cause a change in plant growth? Okay, a couple more seconds. You can still send in your answers. Okay, somebody asked which goes on the x-axis. The independent variable is the input. It goes on the x-axis. The dependent variable goes on the y-axis. Okay, so let's look at this. I want to see if light color has an effect on plant growth. Okay, light is something that I have control over. I can't make the plant grow. I can't just tell the plant to grow or whatever. I can't make it grow. I don't have control over its growth unless I do something about it, unless I water it or unless I give it food, plant food or whatever. But in terms of growth, I as a scientist do not have direct control over making it grow. I need to change a couple of things in order for that to happen. Okay, those things that I can change, like light color, for example, will be my independent variable. The plant growth will be dependent on what I did. Okay, sometimes it helps to look at it in reverse. Okay, for example, if the reverse does not apply, then that thing will not be an independent variable. For example, will the plant growth change light color? Okay, I'm reversing this. The initial one, the original one said light color causes changes in plant growth. Okay, from this it was clear we can change the light color to see if it's got an effect on plant growth. Now reverse it and see if it's gonna be valid. Will plant growth change the color? If it's 2 centimeters long and the light is red, will it growing to 5 centimeters long make the color green? No, it won't. So this is independent on the plant growth. Whether or not the plant grows, the color will stay the same. It won't change based on this plant growing. Okay, let's look at the next one. The effect of antibiotics on bacteria. We want to see how effective antibiotics are on certain bacteria. So those are the two variables that we're looking at. Variable number 1, antibiotic. Variable number 2, bacteria. Which one is the independent variable and which one is the dependent variable, you guys? Give it a shot. Give it a shot. Between antibiotics and bacteria, which one is the dependent variable and which one is the independent variable? Okay, I'm going to give a minute for everyone to send their answers. Okay, so I want to know what the effect of antibiotic is on the growth of bacteria. Okay, remember, independent variables are the variables that we as scientists, good scientists, not just any scientists, we as good scientists change in order to see if it's got an effect on something. Okay, thank you for those who have posted their answers. The correct answer is antibiotics are independent variables and bacteria are dependent variables. So independent variables are the antibiotics. You can change that. You can decide what type of antibiotic you want to use and the amount of antibiotic you want to use. The bacteria will depend on whether or not this antibiotic is effective or not. So this is dependent on the antibiotic. If the antibiotic is strong enough, the bacteria will reduce. If it's not, the bacteria will increase. Okay, so independent, dependent, right? So well done, you guys. Now let's look at the last one. How many days people can eat soup before they get sick? How many days people can eat soup before they get sick? What is the independent variable and what is the dependent variable between those variables there? How many days can people eat soup before they get sick? I'm giving you a minute to send through your answers. How many days can people eat soup before they get sick? Okay. Variable number one is the amount of days that people eat soup. And then variable number two is getting sick. Variable number one is the amount of days people eat soup. Variable number two is getting sick. Which is independent? Which is dependent? Okay. So in order to tell, okay, this is maybe a little tricky. But whether or not people get sick depends on how many days the people will be eating the soup. So this means that the number of days that people eat the soup is independent, and whether or not they get sick is dependent. So this is dependent on the amount of days that the people eat soup. So the number of days is independent and the people getting sick is dependent, right? Thank you for all those who have participated. Okay, let's go to the next slide. From there, you now record your results. So after changing your independent variables and recording your dependent variables, you record your results. You will need to present the data that you collected in a table or a graph or both for easy interpretation. Okay, remember you need a heading or a caption for your graphs and tables. You do get marks for that. Okay, if the mark for that graph is out of 5, okay, 1 will go to the heading, another 1 mark will go to you labeling the x and the y axis. Okay, so we said antibiotics are independent variables, so they will go there. You must write antibiotics or type of antibiotics used or amount of antibiotics used. And here the growth of bacteria or the size of the bacteria. So the independent variable goes on the X and the dependent variable goes on the Y. You will need to write the caption for each axis. You'll get a mark for that. Again, they will give you a mark on the type of graph used. You must use the correct graph as specified in the instructions. If they said represent the information on a bar graph, you must do exactly that, a bar graph. Don't draw a histogram if they ask for a bar graph. Remember what the difference is between a histogram and a bar graph. A bar graph has spaces in between. Histogram is continuous. There is no spaces in between. If they ask for a histogram, you draw exactly that. Line graph, draw exactly that. Pie chart, draw exactly that. Okay, I think my audio got lost. Please raise your hands if you can hear me. Now it has been restored. Can you please raise your hands if you can hear me? Thank you guys, thank you. I'm gonna repeat this. Sometimes you will need to present the data that you collected in a table or a graph for easy interpretation. Remember your heading for your table or your graph. Remember to also caption your axis. Okay, you must write down what variables you are representing on the graph. Use the correct graph as specified in the instructions. If they ask for a bar graph, don't draw a histogram because you're gonna get a mark for the type of graph you used. So the 5 marks are not going to be based on whether you've drawn the correct values. It will be distributed on whether you've written a heading. Have you written a heading for your axis? Have you used the correct type of graph? And then maybe you'll be given 2 or 3 marks on the correct filling in of values. Okay, so please learn your type of graphs and read the instructions carefully to see on what type of graph they wanted you to use. Okay. After reporting your findings, or after presenting your findings, you're going to look at them and analyze them against your hypothesis. In your conclusion, you answer the following question. Has your research succeeded in proving your hypothesis, yes or no? So there will be yes, antibiotic A has a positive effect in eliminating bacteria. Okay, or no, antibiotic A has no effect on eliminating this type of bacteria. Okay, so do you see, disproving a hypothesis is just as good as proving it. Because if you prove that an antibiotic is ineffective, then you won't have to waste money in producing more of that thing because it's not effective. So hypothesis, but disproving a hypothesis sometimes is just as important. Okay. Reliability. How do you increase the reliability of an experiment? One, you can repeat the investigation a couple of times. So repeat the investigation a couple of times to see if it's going to give you more or less the same values. Okay. Other than that, make sure all variables are controlled except for the one that you are investigating. This is very important. Otherwise, the validity of your results is going to be flawed. Make sure all variables are controlled except for the one you are investigating. If it's temperature that you are investigating in the rate of water loss, make sure you keep the light and the humidity and the wind constant, because if you don't, they might have a play in what results you get. So another way to increase the validity of your results is to control all other variables except for the ones you're investigating. Well, sometimes it's difficult to do so, but those that you can, please try to limit. Those that you can control, please try and do so. Okay, that brings us to the end of our scientific report. If you've got questions, there's still a bit of time. You can post them. If you've got questions, you can send them now. Questions that you want us to look at. If you have you looked at your experiments yet, or your practical tasks? Okay. If you were not asked to list independent and dependent variables yet, you can be asked this question in your examination. That's why I'm saying it's very important that you understand this, because it might not be asked now in your task, but it will be asked at some point. Not sure when your practicals are due, but the due date is normally written on top of your practical. The due date is, we haven't had anything yet in terms of June exams, but it will be communicated to you guys via email. Okay. The due date for the task is 14 August. You guys, the due date for the task is 14 August. So you have a bit of time to do that. Okay. Enjoy the rest of your day. If you couldn't get to ask your question now, please send an email to academics@impact.co.za. We will give you feedback, or if you need assistance with the practical, you can send an email to academics@impact.co.za and I'll give you feedback on that. Right? Enjoy the rest of your day. Remember to keep safe. Okay, I'll see you again next time. Bye.